Hello, it's Mr. Neil. In this video I'm going to look at the computer structure topic within the Computer Systems unit of Higher Computing Science. In this video I'll describe the concept of the fetch execute cycle and I'll also describe a number of factors affecting computer systems performance. The von Neumann architecture is a design upon which many computers are based. At the core of the von Neumann architecture we have the processor. The processor is responsible for carrying out the fetch execute cycle. This involves accessing memory locations to read and write data either before or after execution by the processor. There are three main components within the central processing unit. Firstly, we have the control unit. This is the part of the processor for managing instructions. We then have the arithmetic logic unit, or the ALU. This is used by the processor to carry out any arithmetic operations, for example, addition, subtraction, division, and multiplication, or any logical operations, such as AND, OR, and NOT. Registers are used to store data, instructions, or addresses on the actual processor. We'll look at these in a bit more detail in a minute. The processors connect to the main memory via buses. These are high-speed internal connections within a computer. There are three types of buses. A control bus carries control signals from the processor to other components, such as main memory. The address bus carries memory addresses from the processor to the other components, such as main memory. And lastly, the data bus. The data bus carries the actual data between the processor and the component. You'll notice that the data bus has two arrows on it. This is because it's bidirectional. Data can travel from the processor to main memory and from main memory to the processor. We'll see the buses in action a little later. But let's now move on to talk about the registers. As I said, registers are used to store data and instructions on the actual processor. They have the fastest access time of any storage location as they are part of the processor. There's lots of different registers, but three that we're going to look at are the memory address register, and this is used to store the address of the next item of data that is needed by the processor. The memory data register, which stores the data that is either to be passed to or received from the data bus. And lastly, the instructions register. This stores the current instruction that we are decoding or executing. As we said, the term fetch execute is used to describe the process of sending and receiving data to and from the processor and memory. Within the fetch execute cycle, there are two different kinds of operation. A memory read operation, where data is read from memory and is taken into the processor, and a memory write operation, where data is taken from the processor and it is written into memory. Let's have a look at the steps involved in a memory read operation. The memory address register sets up the address bus with the relevant memory location to be read from. The control bus read line is activated. The contents of the address held on the address bus are placed onto the data bus. And lastly, the data bus transfers the data from memory to the memory data register. Let's now have a look at a memory write operation. The memory address register sets up the address bus with the relevant memory location to be written to. The memory data register passes the data to be written to memory to the data bus. The control bus write line is activated. The data bus transfers the data to the memory location specified on the address bus. So now we've looked at the fetch execute cycle, let's now consider factors that can affect the performance of a computer system. Most modern processors are commonly quad-core processors. Increasingly within smartphones and tablets, we're also seeing octa-core processors. This means that there are actually 4 or 8 processors that make up the central processing unit. The more cores present, the greater number of processes that can be done simultaneously. This is known as parallel processing. as multiple different processors can process different tasks at the same time. However, doubling the number of cores from 2 to 4 or from 4 to 8 doesn't double the speed, as all the cores need to communicate, and this takes up some of this extra speed. By increasing the width of the data bus from 32 bits to 64 bits, the computer can transfer twice as much information at once. Therefore, increasing the data bus width increases the performance of the overall computer system. Cache is a small amount of memory which is part of the CPU. It's closer to the CPU than main memory. It is used to temporarily hold instructions and data that the CPU is likely to reuse. Transfers to and from cache take less time than transfers to and from RAM. The more cache there is, the more data can be stored closer to the CPU. Therefore, the better the performance of the computer system. Cache is graded as level 1, level 2 and level 3. The clock speed, also known as the clock rate, indicates how fast the CPU can run. This is measured in megahertz or gigahertz and corresponds with how many instruction cycles the CPU can deal with in a second. A 2 GHz CPU performs 2 billion cycles a second. A computer will normally have a maximum clock speed set by default, but it is possible to change this by editing the computer's BIOS. Some people increase a CPU clock speed to try to make their computer run faster. This is called overclocking. However, there are limits to how fast a CPU can run, and its circuitry cannot always keep up with an overclock speed. If the clock speed tells the CPU to execute instructions too quickly, the processing will not be completed before the next instruction is carried out. And if the CPU can't keep up with the pace of the clock, the data becomes corrupted. CPUs can also overheat if they're forced to work faster than they were designed to work. And it is for this reason that most modern computers have processors with multiple slower cores. So in this video, we've looked at the concept of the fetch-execute cycle and a number of different factors that affect the computer system performance.